If you have a DC motor and you wanted to output a specific torque, you need to provide a specific current. The current and the torque are proportional. But it's not always the case that you can deliver a specific current to the motor. Often you can just provide a specific voltage. So how do you figure out what voltage it is that you want to provide to the motor in order for it to provide that torque that you need? So let us have a look at a motor model where you can use the speed of the motor or the rotational speed to figure out what what voltage we need to put into the motor. So here I am drawing up a model of a motor. So we could put a small m here so we know it's the motor. The motor has two wires and we connect this to an external voltage source, like so. We can call this EXT, so the external voltage, or rather, let's call it UEXT, so the voltage there. Inside the motor, there's some internal resistance, so we'll model this as just a resistor. And then we know as the motor is turning, it's producing some back EMF. So the resistance we'll call R, and the back EMF, that's why I used the E before, we usually call that EB. And that EB is providing as we are rotating, it's providing a current that is counter to the voltage that we're providing. All right, so let's see if we can write up some equations for this. Just using the Kirchhoff law, we can figure out that UEXT is equal to the voltage over the resistor, let's call that UR, plus the back EMF, right? Remember, the back EMF is proportional to the velocity of the motor. The voltage over the resistor we can find through Ohm's law. So R times I plus EB. And the I that we are seeing is the I that's flowing in this direction. So I'll just put I here. Now the I that we want to provide to the motor is this I. Right, so that's the one that's providing the torque through our torque equation. The torque is equal to the motor constant times the current. So effectively we could actually put that in here. Let's try and do that. It'll turn into R times tau divided by K, yeah, plus EB. The EB is also proportional to the velocity of the motor, right? So EB is equal to K times the rotational speed of the motor. So we could also put that in. R times tau over K plus K times omega. There we are. If we want to figure out what voltage we need to provide to the motor for it to provide a specific torque, then all we need to do is that we need to measure the rotational speed of the motor, and then knowing these constants, we can actually figure out what should the current be. All right, so the problem is that really that we don't know K and we don't know R, but we could lump it all together. So essentially we could end up with a drawing or an equation that is some k tau times tau plus k, let's just call it omega, times omega. In this case, k and k omega is the same. But now you see that the voltage is equal to these two, a combination of these two variables, tau and omega, times these constants. So now it's a matter of measuring and finding those constants. In many motor applications, the voltage that we are providing to the motor is not an actual voltage, but rather a PWM signal. But that just means that we could write PWM down here, PWM, and then the constants would change slightly because now we're not working in voltage, but rather a percentage here. But that doesn't really change much, as it's only really changing the value of the constants. So essentially you can make a feedback loop with the speed in order to set the correct voltage in order to achieve the torque that you want. So we're just going to use the equation that we just found, k tau times tau plus k omega times omega. And if we try and draw this up as a block diagram, then we'll have the torque coming in here, the torque reference that we want to achieve. We multiply this with the k tau. We add it with the motor velocity multiplied with k omega. It's an arrow coming from our motor. So in some way we need to be able to get the velocity of the motor, and that turns into our PWM signal, PWM. Wow. So basically that's how you can make a control system for your motor, trying to get the right torque by setting the right voltage.